Hi guys, this is Mr. Lees doing the higher paper from 2023, paper 2, and we're on question 14. So you have the net of an open box as shown here. So the box is a cuboid with height h. So you have to imagine this being made up into a box. So there's the base, that would come up, these two would come up the side, and that would come up here and come up that way there. So this allows you to put in certain expressions for the length of each of these rectangles. If that's 2x, then that has to be 2x. If that's 2x, then so does that. So this now allows us to get an expression for the area of the net in terms of h and x. So let's get on with that. So there's the net with some more expressions for length in there, length there, length there, length there. So let's get the area then. So we have 1, 2, 3, 4, 5. So the area of 1 is h times 2x, 2, 3x times h, 3, 3x times 2x, 6x squared, 4, and you can see it all coming out there. Tidy it all up, you get the area is 10xh plus 6x squared, and that's a formula for the area. Then it says here, given that the area is 7,200, show that the volume of the box is given by this formula here, 4320x, take away 18 over 5x cubed. You'll notice that formula V has got nothing to do with h in it, so we need to get rid of h, and this is how we do it. So there's your answer to part A. And given that the area is 7,200, we can now set this equal to 7,200. And we move the plus 6x squared over to become minus 6x squared. And we divide by 10x, and that leaves the h there. So this is our expression for h just using x's. So the volume of the box will be length times breadth times height, 3x times 2x times h, and we know what h is now. It's 7200 take 6x squared over 10x. So we're just gonna, then we have it there. And what I did here is I moved the 10 over to here and simplified that to 3/5. And there's x squared over x, so we have 3/5 x times 7200 takes 6x squared. So using the calculator, of course, 3/5 times 7200 gives you your 4320x, take away, and 3/5 x times 6x squared is 18 over 5x cubed. And that's a formula that they want you to find for the volume. And then determine the value of x that maximizes the volume of the box. Okay, so here we have it here. The volume is 4320x, take away 18 over 5x cubed. The maximum volume occurs when dv by dx is 0, so we differentiate that. 4320x becomes 4320. 3/18s give 54 over 5x squared, 1 down from 3 to 2. That has to be set equal to 0. So that, take away that, gives you 0. So of course, logically, that has to be 4320. And divide by 54 over 5. And you get 400. X squared is 400. Root 400 is 20. Does this correspond to a maximum? Well, let's test it. So there's x to be 20, and we're going to get the gradient of the graph, if we were drawing one, either side of 20, 19 and 21. When you put 19 through that there, you get a positive number, so it's a positive gradient there. 20, of course, gives 0. 21 through dv by dx gives you a negative. So positive, 0, negative, that is a maximum. So x equals 20 does indeed correspond to a maximum volume.